city, group green, group Midori.
Konnichiwa. Watashi wa Gaki.
Buko wa Rishi.
Hiki ni kite kuruta.
Arigatou gozaimasu. Nihon wa subarashii kuni desu.
Good afternoon, ladies and gentlemen. I'm Hechiko Shimasa.
And I'm Aigochi. Thank you all for coming today, and we hope you enjoy our presentation. These are the pictures of New York City, which is our choice for this project. New York City is a very important city in America because it is a cultural hub which many tourists come to. It is also a major economic center of the world.
However, New York is not perfect and it experiences 4 key problems that we target during this. These are traffic, storms, energy, and pollution. And now Gabby will speak about traffic.
Traffic is a concern because of evacuation problems within the city and outside of the city as well. So to rearrange the transportation system now and correct it from transportation within the city, we are going to use a layered transportation system. As you can see, the first layer, it would be used for hovercrafts and other aviation systems. Underneath that, we would use monorails, and there would be different layers of monorails for different tracks and directions. We would also have a layer for cars, and depending on the speed, it would go on a certain way. The last layer will be used for pedestrians and bicycles.
Now our plan intends to remove the subway system, which we will expand later, but we will increase monorail usage, which will compensate for this.
New vehicles will be instilled in our future society, and we will use hovercrafts and ferry submarine systems. Ferries would be used as ferries during regular seasons, and after natural disasters, if appropriate, would be used as submarines. Next, I'm going to talk about storms, which we think is the biggest natural disaster concerns in New York City. Some of the problems that storms could cause include flooding and wind damages. So heavy rain causes flooding in the underground subway system and also in some of the lower floors of the buildings. Moreover, strong winds will cause roofs of the buildings, cars, and other heavy objects in the city to blow away. And in order to come up with our solutions for this, we categorize the solutions into 2 parts, which includes preparation and dealing with the aftermath of the storms. So first, I'd like to start off with preparing for the storms. The main problem that we have for storms right now is that it floods the underground subway system. So then why keep the subway system? Getting rid of the subway solves this problem. So we decided that converting the subway stations and the tunnels of the subways into a reservoir would be a good idea, and we're going to use that to store water. Moreover, we're going to put up these sensors, which Toshiba, the picture on the right is a sensor by Toshiba, and we're going to collect data from these sensors and use it as a preparation of storms. For example, we can put up these sensors on the ocean floor, which measures the height of the waves, and if it goes over a certain limit, then we can open up the reservoir where the water can flow in. Moreover, we can put up the sensors on buildings which measures the speed of the wind, and when the wind speed goes over certain limits, then shutters can come down the windows so that it doesn't crack, and wind barriers along the borders of the city can come up as well to protect the city from the wind. The second part of solving the problems of the storm was dealing with the aftermath, so I'd like to go on to that. And our first solution for this is gel bubble leads, which absorbs water and it prevents the streets from flooding. The second point is that storms cause ripped out trees and damaged vegetation, so we can use these organic materials for biomass energy. Finally, our third point for dealing with the aftermath is that there are many buildings in New York City which have flat roofs, so water remaining on the roofs can be collected and fallen into the reservoir, in which case we can use the potential energy of the water to generate energy.
This transitions into what we look at for solving New York City's future energy issues. New York City is susceptible to overusing technologies that are detrimental to our environment, and so it's our initiative to make more innovative and clever solutions that are alternative energy sources that are far more superior in helping the environment. Now, we look at 4 key aspects or categories of solutions. The first uses photovoltaics or solar power, and it uses it in paint. Now, this paint, unlike other paint, as I said, will generate energy through the sun and can be applied to the external surface of buildings as well as to automobiles and other vehicles. This will be very useful, especially on the automobiles, because they are so frequently used, and this will allow for dynamic energy production as opposed to static energy production. Now, to expand on this, we move on to piezoelectrics, which can be used both in tires and in plumbing. Now, piezoelectrics are traditionally considered to be energy generation through heating something. However, research at Stanford University shows that we can also use piezoelectrics in the future as a means of generating energy through pressure. Now, on the axles of vehicles, we see there's a tremendous amount of pressure, and there's a similarly high amount of pressure in plumbing systems throughout New York City. And because these systems are so common, we can produce a tremendous amount of energy in the span of the next 20 years. Now we move on to something very futuristic, and that is using friction as a means of generating energy. Friction is what causes heat to be generated as a byproduct, and because of this, we can use the heat to be converted into other energies such as chemical energy or kinetic energy. We can also use heat as a means of evaporating water in the event of a storm, because heat is already heat, and we can use it as a source of evaporation. And finally, we move on to microbial fuel cells. Now, these cells, at their simplest construct, take organic compounds and synthesize them to generate energy external to themselves. Now, we can use the reservoirs that were talked about by and we can use the materials in these reservoirs that are already present as a means to fuel the microbial fuel cells, which will fuel tomorrow's communities.
So there are 3 types of pollution in Japan and New York City, and they are air pollution, water pollution, and fire pollution. So first, I'll talk about air pollution. One of the biggest causes of air pollution in New York City is the emission gas from cars. It includes 10.4% of CO2, which also has a great effect on global warming and on our health. In order to solve this problem, we should find some way to separate CO2 from the emission gas. Nowadays, ways to capture CO2 from emission gas of coal-fired thermal power plant has been researched. By this system, we can not only separate CO2 from emission gas, but we can also reuse to capture CO2 in various ways. If we can apply this system to cars, we can reduce a great amount of pollution in New York City. Actually, Toshiba is now aiming to complete the system to generate 250 megawatts of electricity by 2017. So it is very likely for us to use the system for cars. So now I'd like to talk about the water pollution. The best solution, we think, is bioremediation. We use biological organisms, especially bacteria, to clean dirty seawater. They are environmentally friendly. Also, they are accessible to places without excavation. And it's also cheap, which is very efficient. It was actually used during the Gulf War in 1991, when an oil field was destroyed. So finally, I'll talk about the garbage problems. The best solution, we think, is biodegradable plastic. The feature of this plastic is that they can be decomposed by bacteria. Therefore, nothing will be left after all except for CO2 and H2O. However, there are several disadvantages that must be overcome. They are expensive, and also they can be broken easier than normal ones. Also, they're very difficult to reuse and recycle. So we have to overcome these problems. That's all.
And I would like to thank all of the people who have come here today and
Arigatou gozaimasu.